there are 4 inequality symbols that we're going to graph today. There's a 5th one you learn about in Algebra 2, but we're not talking about that one today. What does the less than symbol look like? Y'all holding up your left hand, aren't you? Yeah, your left hand is your less than sign. So with your highlighter right now, I want you to write the less than symbol in there. We're going to be using our highlighters a lot today. The greater than symbol is your right hand. So it's the open alligator mouth because it's bigger. Greater than. It's the foldy one. What does less than or equal to look like? Left hand with the line underneath it. Very good. Left hand with the line underneath it. It's smaller at the beginning. And greater than or equal to is obviously the right hand with the line underneath it. Greater is the right hand. Less than is the left hand. That way you can remember what they look like. Yes, please. With the highlighter. Now, when we learned the one-dimensional type of graphing on a number line, we used an open or a closed circle. Do y'all remember that the symbols without the line underneath it had the open circle? Yeah. All right, so that's still the same. That has not changed, that our open circles go with the ones without the line underneath it. It's like there's a hole in those symbols for opened or closed. Closed is the filled in version because there's a line underneath it. If you have to write more, you have to write more. But moving to 2 dimensions means we not only choose an open or closed circle, but that we also have to have either a dashed or a solid line. When we graph them and put our rulers down, we're not just going to go bloop and draw a straight line. There are times that we're going to have to draw a dashed line. Now, your dashed lines go with the open symbols. So for less than, you are going to use a dashed line. For greater than, you're going to use a dashed line. For the or equal to's, so less than or greater than or equal to, you're going to use a solid line. So those kind of feel like you're graphing like normal. So now we have to qualify with dashed or solid. These are the things you're going to have to memorize for sure. Shading, since this symbol says less than, things that are less than are smaller, so we're going to shade or color in the half plane that is below that line. For things that are greater than, that's bigger or above, so we're going to shade in or color in things above that line. Oh, crap. Less than or equal to is below because it's one of the less thans. Greater than or equal to is above because it's one of the greater thans. That's all the information you're going to have to memorize. This is what Desmos won't do for you. Desmos will graph lines, so y equals mx plus b lines, but it won't graph inequalities. So this table right here is something that you're going to have to make sure you have memorized, and we're going to ask you, those are the questions that'll be at the door for like the next forever, okay? Dashed or solid, shaded above or below. That's something we're going to have to memorize. Desmos will help you get a line, but it won't help you continue and actually graph the inequality. First type of question we're going to have today, and this is just like a little bitty question. This is like what it's going to be at the door. I'm going to ask you, are these lines dashed or solid? Are we going to shade them above or below? We can tell just by looking at the equation the answer to both of those questions. Only if that equation is solved for y. So if your equation is not solved for y, which means y is by itself, you must isolate the y. The reason we have to do that is because occasionally when we're solving for y, we're going to have to divide by a negative number. Who remembers what happens with an inequality sign when we divide by a negative number? It flips from either greater than to less than or less than to greater than. So we're going to have to take some time to remember that if it's not solved for y and we're starting to solve for y, that we flip that symbol. But like this first example, this one has the y isolated. So I want you to highlight the symbol right now. And we're going to decide based on this symbol, since the y is isolated, when I graph this, would it be dashed or solid, shaded above or below?
Dashed and above.
Dashed and above. That symbol is not one of the equal to's, so it's dashed. And it's greater. That's my right hand, so it's greater. So it's going to be shaded above. The second one, let's highlight the symbol. We will solve for some of them, but this one's already solved. So we can look at the symbol. Dashed or solid?
Solid.
Solid. Above or below?
Above.
Very good. Does everyone know where she's getting the above from?
You said solid.
It's greater. Greater is above. Now let's look at this third one. Is the y by itself? No. So we have to solve it for y, but no big deal. We've been practicing that. So if I wanted to solve this inequality for y, what would I have to move first?
Check x, so it would become a -2.
Really? What? It would just be a negative x because it's just negative 1x. Okay, so she's saying you move the x from one side to the other. Is there anything in front of the y that I need to divide by? What's in front of the y right now? 1 is fine. 1 is the only thing that it's fine not to divide by. -1, you have to divide. 2, 3, 4, 5, 1800, you'd have to divide. So this equation is actually y less than negative x plus 0. But I'm not going to write that. Now that we've solved for y, we can answer the question. Dashed or solid?
Dash.
Dashed, because there's no line underneath it.
And below.
And below, because it's less than. Does everyone see where they're looking back up at the table to answer this until you have it memorized? That's where they're getting this information from. Look at this one. I'm going to give you 2 seconds to solve it for y. And by 2 seconds, I mean 10. 10 seconds to solve this for y. So Leslie said, all right, we're going to solve this one for y. And I'm sure she moved the 2x to the other side.
You become -2x.
Yeah, and so then I have a positive y, that's good, less than negative 2x minus 4. Did y'all solve it for y like this?
I didn't even solve it at all.
This symbol, less than, like Leslie said, is going to be dashed and below. Dashed and below. If we start to solve the middle one on the bottom row, what would I move first?
The 3x.
Cool. And I move it by using its inverse operations to go to the other side. It's going to be negative y greater than or equal to negative 3x plus 4. We're going to have to divide this time because there's not a 1 in front of y. There's actually a number there I have to isolate it from. So there's a negative 1 right here that we divide. Now, what should you be remembering right now?
You need to swap the inequality.
What do you mean by swap the inequality?
Flip it to its opposite.
Correct. Okay, so since I'm dividing by a negative, when I write this down, bloop, and I'm going to write it over here because I ran out of space. This would be y less than or equal to negative 3 divided by negative 1 is 3. 4 divided by negative 1 is minus 4. So if I had not solved it for y, I might have answered this question wrong because I had to flip the symbol. That is why we have to solve for y to have the y isolated before we can answer this question. Based on this now, dashed or solid?
Solid.
Above or below?
Below.
Below. You would have said above had we not solved it for y, which is why we definitely need to do that. I'll get out of the way.
Miss, we're gonna move right here.
This last one is yours. You don't have to solve it for y, but really quick, I want you to answer on your paper. Dash solid, above, below. Since this symbol is greater than or equal to, is it dashed or solid? Solid. Is it above or below?
Above.
Above. Awesome. Okay, so I bet you're wondering, Miss Cooley, what do you keep meaning like dash solid above below, right? I haven't shown you what that means. So right now in your Desmos, the web version, again, this will not show up whenever you graph it on test mode, but I want you to type this equation in, the very first one. I want you to see what I mean by dashed and above. You type y greater than x plus 3. It's going to graph it for you. And we're going to end up learning how to graph this on our own today without the use of technology, but I want you to see what it looks like.
Okay.
I'm going to pop over to Desmos real quick to show you. So we kind of just talked about this when we were looking at Desmos, but the second part down here says, how do you determine if the coordinate x comma y is a solution? Okay, it is a solution if it is in the shade. So in that colored region that Desmos showed up for us, or when we graph it, if it's in the shade, but not, underline, underline, underline the word not, but not on a dashed line. Very good. Because dashed lines is exclusive, it falls through. So we can't continue, or we can't count solutions that appear on that dashed line. Okay. To help us learn today, we are going to use Desmos on these, and I'll show you what test mode looks like compared to regular version. But number 1 says, which ordered pair, x comma y, is in the solution set of 2x minus 5y greater than or equal to 10? Can I graph this equation right now?
No.
No, what do I have to do first? So Abby, what am I going to move first to solve for y?
The 2x.
Very good. So I'm going to subtract the 2x from both sides. It's gone. And my next line of this equation would say negative 5y greater than or equal to negative 2x plus 10. Kayla, what would I have to do next to continue solving for y?
You gotta divide
I do have to divide. What am I going to divide by?
on a -5.
Very cool. So I divide by -5 everywhere, and you're like, internal alarm should be going off because I just divided by a negative when I'm using inequalities. What do I have to do?
The symbol.
What about the inequality sign? Yeah, I have to flip that inequality sign to its opposite when I divide or multiply by a negative number. Then we do have to do all the, actual multiplying and dividing here. So this would be y less than or equal to -2 divided by -5, which is 2/5. And then 10 divided by -5 is -2. Consult your calculator or your brain if you're like, where'd you get those numbers? I calculated that. Now, we have something that Desmos would graph for us. For right now, I want you to go ahead and use the web version. Type this into Desmos, and then begin typing in each of your answer choices here to see which one appears in the solution set. So we're going to type in the equation, and then we'll literally press like parentheses, 0,5, close parentheses, and that coordinate is going to show up. We're going to figure out which one of those answer choices is in my solution set. I'll do it with you. I'm cutting over to Desmos. So if it's not a solution, since this particular one is asking us which one is not a solution, we'd eliminate them. So we said the only one that was even close was answer choice B because it was on the solid line whenever we graphed them all on Desmos to see what it looked like. So we would know that is the solution. If it's a dash line, it just wouldn't count. There would be a correct answer. So Shalai's question was, what if we graphed all of these and it was a dashed line and that 5,0 showed up? There would have to be another answer choice that was in that shaded region, like over here, or else it's a bad question. Yeah. Okay, you guys have number 2, which is, for me, it's called a naughty question. Y'all ever heard of the naughty questions? Why do you think it's called a naughty question?
It's a bad question.
No, but what do you see in the question? It says not.
So we gotta pick the wrong answer.
This is a naughty question. So we want to know this time which ordered pair is not in the solution set. Can I graph this equation the way it's given to me?
Yeah.
Yeah, so I want you guys to take this one. You guys go ahead and figure this out for me using the Desmos web version. I'm okay with it today. Which ordered pair is not in that solution set? I'll give you some time. So again, this was a naughty question, so we're looking for the one that was not in the solution set. This one was, and this one was, which meant that answer choice C is my naughty question. And one last time, just because Desmos will only graph the equals part, a regular equation, we need to be able to know which side needs to be shaded above it. We're gonna, yeah, it's fun to me. Snap, snap, clap. We're gonna move to the inside of this packet, please. So open it up. Now we already sort of talked about this.
If it is in the shade, not on a solid.
We are going to be graphing these solution sets ourselves by hand. From here on out, you can check using Desmos, but you're doing it by hand. This pink piece of paper that you have when you walked in, the back of it has some graphing help if you need help graphing. But like Mickey said, we are graphing solution sets, which means if it is in the shaded region, but not on the dashed line. That means it's my solution set, and our job is going to be able to graph them ourselves right now. You good saying that? Okay, there's 3 steps. You graph the inequality, which is just y equals mx plus b, the way we've graphed since forever. But you have to choose the boundary line, which means you decide if it's going to be dashed or solid, and you get to shade either above or below. So it's just like normal, except when you put your ruler down to draw your line, sometimes you're going to have to make it dashed instead of just drawing a straight up solid line. And then you get to color or shade. What? For real?
I don't like coloring.
I love it.
Way out of my league.
All right, let's look at number 1. Oh, sorry. Yeah, I'll go back up. We're going to do number 1. Is number 1 in a format that I can graph? No, so we have to solve it for y. That's standard form. We want to graph from slope-intercept form. So we're going to come in here and we're going to solve it for y. The first thing I do to solve for y, I have to move the x term. Cool. Dashed. So then I have negative 2y greater than negative 6x minus 2. Am I done?
No.
No. What else do I have to do?
You gotta divide and swap your inequality.
Negative 2 by each one.
I divide by negative 2, and since we are dividing by a negative number,
Swap your inequality.
bloop, flip the sign. But I'm going to write it over here because I ran out of space. So 2 divided by 2, that's 1. This is y less than now. Negative 6 divided by negative 2.
Where you get that 6 from?
Where'd I get the 6 from? I moved it over there.
And then,
Oh yeah, my bad.
well, it's just 3x.
Negative 2 divided by negative 2 is a positive 1.
Is that a 2 with the arrow?
But I thought you were about to say
What?
ratatouille.
Is that a 2?
No, that's me trying to like draw the fact that my inequality sign is flipping over. Bloop. So it was greater than here, and now it's less than because I divided by a negative number. Okay. At this point, is this in the form that I can graph?
Yes.
Let's circle our slope. What's our slope?
3. 3.
Thank you. The 3 is my slope. Let's box our y-intercept. Our y-intercept is 1, which means this is how I'm going to move, and this one is where I begin. Now, my move number is typically a fraction. So right now, what is 3 written as a fraction?
3 over 1.
Okay, tight. The only other thing I have to know, based on this symbol,
Is it dashed and shaded above?
is it dashed or solid?
It's dashed.
It's dashed.
Is it shaded above or below?
Below.
Below. That's all the info I need to graph. We go back to graphing like normal, except when we draw the line, we're going to make it dashed. So follow along with me. We said we begin where?
At the
1.
origin.
At the origin.
The
1.
We at 1.
At 1, at my y-intercept, which was 1. That's my
You go up.
beginning number.
And you rise 3 and run 1.
I rise 3, run 1. Rise 3, run 1. This should sound pretty like a broken record, right? We've done this before. This time,
We have to color?
2, 3.
You gotta draw your line.
We do draw my line, but we said what kind of line is it?
It's dashed.
I can't find my ruler. Oh, I found it.
Why you say it like this?
I don't know.
Like this?
So, I draw my line, but I put my ruler down, and instead of just drawing a straight line in between them, I draw a dashed line. Because it's less than. Doesn't matter how you do your dashes. If you can make it more dashy than me, that's cool. As long as it's got holes in it to indicate that it's a dashed or exclusive line, I'm cool. Now, we do need a shade below it. Sometimes finding the above and below is confusing. Always go to your y-intercept and draw an arrow either up or down. But we want to go down below, so that's the side that I'm going to shade in. You can shade using your highlighter so it's nice and fun and colorful. But this is the shaded region below. If you want to make sure you're correct, you can graph this in Desmos to check. But remember, it's a checking tool. It's not the end-all, be-all. Let's play a fun game right now.
No.
It's really fun. Thank you for the enthusiasm. Okay, I'm gonna plot a coordinate on this graph, and you're gonna say yes or no. Yes if it's in the solution set.
Yes.
No if it's not. Ready?
Yes.
Where's your
Yes.
Yes. Okay. How about this one?
No.
How about this one?
Yes.
How about this one?
No.
Thank you. Why is that one not?
It's on the side.
It's on a dashed line. Okay, what about this one?
No.
What about this one?
Yes.
What about this one?
No.
Okay, I think we get the game, right?
No.
Okay. Cool. I know, I love it.
I don't think you considered that a game.
We always been
Huh?
in the
I don't
day.
think you can consider that a game.
That was a fun game. No? No? Okay.
Yeah, it was a very fun game.
Thank you. So here's what I want. I want us to practice with the first two. If you can graph the first two, I want you to keep going. We're going to do the first two before we transition to the other part of notes. You're in charge of the next two, but again, if you can do these next two, I want you to keep going. Are the next two written in the format that I can automatically graph?
Yes.
All right, I want you to try them. You got 2 and 3. Boom, let's go. On number 2, if we circle the slope like, here, I'm going to zoom in actually. If we circle the slope like we usually do for these kinds of problems, I'd be circling -1 and boxing +1. So my slope is -1 and my y-intercept is 1. Okay. Based on this symbol, is it dashed or solid?
It is solid.
Above or below?
Above.
Okay, cool. Now I had a good question from some people, like how do we know how to move? Your slope is always a fraction. So -1 is actually the fraction, -1/1.
And your B is your y-intercept.
Very cool. So I'm going to begin with my y-intercept, like Kayla said, at 1. I'm going to go down 1 and right 1, down 1 and right 1, down 1 and right, until I know that I can draw a good solid line. I can actually just draw my solid line this time. Across the graph. Oh, I almost missed. And oh yeah, it's not my best, but you get it. And then it's going to be shaded in above. How'd we do? Yay. Let's check number 3. What's the slope on this one? And that one's already a fraction, so I don't even have to like think. And then my y-intercept is this one going to be dashed or solid? Dashed above. So that means I'm going to begin at -5. 1, 2, 3, 4, 5. And I move. I go up how many? And over.
You go up 1, rise 4. Run 4.
Very cool. And this time, I don't make a solid line in between them. I make a dashed line. Let's see if I can do better. It's hard with this pen. There's my dashed line. And I need to make it above. Now, I had some questions on this, and this one's pretty easy because it's kind of flat, so there's very obviously an above and below. But there are times you're like, I don't know which way is above and which way is below. If you're confused, put your pencil on the y-intercept and literally go up or down. This side is above, so that's the side that I would shade. If it was super steep, sometimes it's hard to tell what's actually above or below. So if you're stuck, go to the y-intercept, think up or down, and whatever side it goes to, that's the side that's above or below. Which one? Oh, so like, hey, will y'all look down at number 7? Is this what you're talking about?
No.
Okay, I'm going to do number 7, and then we're going to switch just because he has this question. Is this a Hoy or a Vux line?
It's
It's a Vux line because it starts with X. What kind of slope does this have then?
Straight.
It has an undefined, because remember the middle letter is my slope. That's an undefined slope, which means I'm going to have a vertical line at -3. Is this one dashed or solid?
It is solid.
It is solid. Am I going to shade in above or below?
Above.
Above. Now, if I draw this vertical line, and I think this is what Mickey's talking about here. If I draw on this solid vertical line right here, and then I tried to do that trick I just talked about of it being above, there's like, the line is above. right? If I go to the intercept and I look up, like it's more of the line, I still don't know which way to graph. So my question is this. Above means bigger. Are numbers bigger on the left or are they bigger on the right? So this would be the direction that I'd shade because that's technically above or to the right. That was a bonus for you guys. I didn't do that with any other class. So if you're concerned, I'm going to film the rest of the 3 examples we didn't do and put it in this video, but I'm not going to do it live in class. So if you want to hear the rest of them, it'll be on YouTube. Is that cool?
Maybe.
Okay, we're going to switch over to the other set of notes. They look, it's the little half sheet, so find yourself on the half sheet.
Where though?
The half sheet looks like this.
So we're going back to talk about the 3 that we didn't show during lecture here. This equation is not solved for y, so we would have to solve it for y to begin. We'd subtract the x from both sides, and then we'd have to divide by -1. Now dividing by a negative when I'm dealing with inequalities means that I also have to flip the inequality sign. This equation would, or inequality would now read y greater than, I'll put the x's first, -1 divided by -1 is a +1 x, and then a -2. My slope is 1, my y-intercept is -2. This is a dashed line shaded above because of the symbol greater than. Now remember, if we hadn't solved for y, we would have dashed and solved, or we would have shaded the wrong way. We begin at the y-intercept of -2, and we move by going up 1 over 1. Now I know this is up 1 over 1 because the slope of 1 is the fraction 1 over 1. Now with this dashed line, once I feel confident that I can draw a dashed line, come in with my ruler and I draw myself a dashed line. And we said it's shaded above. Now above is above the y-intercept, so that is this half plane that I would shade in. Number 5, same thing, it is not solved for y, so we would have to do the solving for y first. To take the x to the other side, you have to use inverse operations, which means I add it to the other side. The y is still not isolated, so I would divide by a 2 on each term. Now I don't have to flip the sign here because I didn't divide by a negative. This would just be y greater than, I'll put the x first again, 1 divided by 2x plus 1. Means my slope is 1 over 2, that's my rise and run. My y-intercept is 1. Begin at 1 on the y-axis, and we create more points by going up 1 and to the right 2. So now that we've done that part, we can come in and we would want to graph a dashed line shaded above because of the symbol greater than. So we would draw our dashed line through the points, and we would shade above that line. Now again, above is above the y-intercept, so we would look above the y-intercept and shade in that half plane. All the solutions, again, are in the half plane that is shaded. So as a quick review, solution, 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 not a 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 solution because it's a dashed line.
Yep. Because today not only are we graphing inequalities, we're also going to write inequalities. And this is really cool. I actually really like this stuff because this is money management here, okay?
I don't.
Money management.
Don't like money management.
So about a week ago, maybe a little bit longer, we learned to write systems of equations from word problems. Oh, it was Halloween because I was dressed like a praying mantis. But we learned to write systems, the hands. We learned to write systems of equations from word problems. We're going to do the same thing today, but we're going to only have one inequality, and instead of equations, we're writing inequalities. Okay? There are some translations we need. So instead of saying is translates to an equal sign. We're going to see words like is more than, over and above, is less than, fewer than. Those translate to our inequality signs. The is more than
Greater than.
is greater than.
And the less is
That's pretty self-explanatory. But the two more important ones, because these actually show up in money management / like in your future, is the phrase is no less than or a minimum of or at least.
At least, so isn't it greater than or equal to?
This one is greater than or equal to if it says is no less, which is confusing. Can't be less than that, so it has to be bigger or exactly equal to it. The is no more than
It's greater to or equal to.
is less than or equal to,
It can't be bigger than.
because it cannot be bigger than whatever number. It has to be smaller or equal to that number. These are the two that you'll see the most often, the is no more than or is no less than, in these word problems. That's pretty much the typical way to talk about it. I'll walk you through these three problems here. Let's talk about Mandy's problem. Mandy. Mandy is buying plants and soil for a flower bed for her mom. Oh, so nice. Bags of soil cost $5 and each plant costs $12. She can spend no more than $100. Write an inequality that represents the situation where X represents the number of bags of soil and Y represents the number of plants. All right, well, they told us what each of these things stand for. If we define our variable, what did they say X is?
X was
Plants.
soil.
Number of soil.
Number of bags of soil.
And then Y is number
And Y represents the number of plants made by.
Cool. And Y is the number of plants. They told us what the variables are. They're going to do that for you. And then we go back, reread the problem, and we highlight important numbers. I see that soil costs $5 and that each plant costs $12. I see that she can spend no more than $100, but that no more than is super important.
It's
Hold
less
on.
than or equal to. Less than or equal to.
Cool. So when I put these things together, I'm going to say that there's $5 for every bag of soil, that's X,
Plus 12.
plus $12 for every plant,
Equal.
not equals.
Is greater, less than or equal to
less
100?
than. Greater than.
Less than or equal to. No more than means less than or equal to. Mandy can spend, she only has $100 in her pocket. She can spend up to $100. No more than $100. She can spend 99, 98, 97, 96, all the way down, smaller. She can spend exactly $100, but she can't spend 101.
What about 150? 100.
Still too much. She only has $100 in her pocket. She can't spend more than that. That's an expensive flower bed for $100. Let's talk about Jennifer. Jennifer is planning a holiday.
What holiday?
I don't know. Let's pick one. What?
Turkey Day.
Turkey Day. Jennifer is planning a holiday for Turkey Day. The hotel costs $50 per night, and her flights cost a flat fee of $150. She can spend a maximum of $500 on this trip. Write an inequality represents a situation where X is the number of nights that Jennifer spends on her trip.
Why is she not at home?
Wait, X is
I don't know. Maybe she's an adult. She has to travel to go home. I don't know.
That's kind of sad.
It is kind of sad. Maybe she's visiting family on this trip, but they made her stay in a hotel. I don't know.
No, my grandma does. I can adopt her.
That's nice. So let's read this again. We see the key words. Since we know that X is the number of nights, we see that the hotel costs $60 per night. What does the word per mean?
multiple, so it's a variable.
Which means that it's my slope. Okay, cool. Yeah, awesome. And then it says that her flights cost a flat fee of $150. What does flat fee tell me?
That's the amount she has to pay. Exactly.
It's the initial value. It's the Y in herself. It's by itself. All the things y'all are yelling at me? Yes. Okay. It says she can spend a maximum of $500. But I see the word maximum.
Which is
Less than or equal to. So let's put it together. We said that Mandy has $60 per night. So that's multiplied. And a flat fee of $150. That's my initial value. Has a maximum of $500. What symbol means maximum?
less than or equal to.
That's my most popular symbol to use because money management.
It is?
Yeah.
Less than?
Usually you have a max budget,
Okay.
so it's usually going to be less than or equal to. I'm not going to say it all the time, because sometimes it's not, but that's typically like the one you'll use the most in life. Hey, speaking of your life, this one's super relevant. It says, in order to get credit for Algebra 1, you must earn at least a 70. Write an inequality that represents a situation where X represents your overall semester grade. So X is your overall grade. And we know that your grade must be at least a 70.
So that's your initial
Oh,
grade.
yeah. I showed up, don't
That's
like
your
that.
flat fee, right?
This is big facts right here. Okay? That means my overall grade must be at least a 70. What goes in between my overall grade and 70?
It has to be, wait, your overall, so less than, no, it has to be, oh, greater than or equal to.
Your grade must be greater than or equal to a 70 for you to get credit for Algebra 1. You can make a flat 70 and get your credit for a half semester, or you can make more than a 70, but it can't be less than a 70.
Like 69.9999.
That would round up technically to a 70.
69.9.
69.9 rounds up, 69.5 rounds up, 69.4.
What about 69.4555?
Depends on how we're rounding. I would still say no. Okay. So those words, you're going to have to be able to translate the words into the inequality signs and then write some lines. Next class, we're going to be taking a quiz over writing inequalities from these words as well as graphing them. So bring your notes back with you.